All right, we're going to go ahead and get started. So today we're going to be building a hybrid architecture with InfluxDB. This is a hands-on workshop, so if you have your laptop ready to go, that'd be great. If you don't have a laptop, you're welcome to either pair program nicely with the person next to you, or we will be giving you a lot of resources that you can take away from here and do this at home on your own time and speed. So first things first, I just wanted to introduce InfluxDB University, which is basically where we keep a lot of our free online self-paced learning materials. It's basically where you can do courses on your own. You can also earn things like LinkedIn badges and such. And this is one of the workshop trainings that we've done before. We sometimes occasionally do it live, occasionally do it over the web. It just kind of depends, but this is a more elongated live version. And these are just a few of the other self-paced trainings we offer on the university. Your trainers today are going to be me, Zoe Steinkamp, and then this is my coworker Jay as well. He'll be taking over. We're kind of going to be going back and forth. It also helps us if anybody gets stuck in the room, we can kind of come and help you in real time. So you don't have to, so if you do need any help, please feel free to just raise your hands. We're here to help. So for the training agenda today, we're going to be starting with the edge. So we're going to be going over data collection using Telegraf, which is an open source ingestion agent. There's about 300 plus plugins. Today we're going to be focusing on the MQTT one, but this kind of workshop could be done with any of the plugins that are available. From there, we're going to practice a little bit of downsampling, which is basically just cleaning up the data before you send it up to your cloud account. And we're also going to be doing edge to cloud replication, which is basically edge device being, for today, it's going to be our laptops, but normally you could imagine this as a device out in a literal field, like far, far away from internet connectivity, or just something you want to back up. This can even be something in a factory floor where you're never quite sure if internet could possibly go down, but the data still needs to be stored. That becomes an edge device, basically. So edge to cloud replication is very important normally in the IoT sector. From there, we're going to talk a little bit about the cloud. Specifically, we're going to talk about Grafana, actually. So for those of you guys who haven't ever used it before, Grafana is basically a visualization tool. It allows you to visualize your data. You can do graphs as well as a few more advanced visualizations like mapping, etc. So, and then also it allows you to do alerting. Things like when the data reaches certain thresholds or goes below certain thresholds, go ahead and send me. It can be configured in many ways, but it's commonly email or Slack notifications. I don't work for Grafana, so I'm not going to talk too much about it, but there's quite a lot of things you can do with alerts. You can send them as you need to. And then finally, we're going to go into SQL one-on-one, which is basically just going to walk us through some of the SQL queries that you would expect in this IoT architecture that we're building for the project. It's not actually SQL 101. We're not starting from quite the scratch, but we're just going to go over a few of the queries, some of the mathematical ones that you might use, etc. And then next steps. Throughout this training, you're going to see a lot of QR codes. These are obviously QR codes that you can take a photo of here on the screen. This also might be uploaded later online. You're going to be able to find most of these resources, but just do keep in mind the next steps will have everything kind of contained at the end. So the scenario that we're going to be going over here, a country is currently experiencing a national emergency due to an electric grid failure. We call this winter in Texas. To mitigate the power shortage, the government has deployed generators in the remote regions of their country to power the most remote villages. The problem, the villages are still reporting outages due to the generators running out of fuel. So how can we as IoT specialists counter this scenario? So this is an architecture overview here. So as you can see, we have our generators on the far left, and we have 3 generators. This isn't a very big country, not too many remote villages. We're just doing a smaller scale here. So with our 3 generators, they're going through an MQTT broker with Telegraf, which again is the open source ingestion agent that we'll be going over, which then sends the data into InfluxDB open source, which then uses edge to cloud replication to send it up into the cloud. This allows, just in case the InfluxDB OSS is on, like I said before, an edge device, just in case the connectivity with the cloud goes intermittent because of the power outage that we're dealing with currently, it will still store the data locally, and then when it reconnects with the cloud, we'll be able to get a better full view picture of what the amount of fuel is in each of these generators. So we had this slide up originally for some of you guys who came into the room, but basically these are the training session requirements. It's that you have an InfluxDB Cloud account, because that's the cloud account we're going to send the data into. The InfluxDB CLI, which will allow us to do command line commands, basically, command line controls. Docker, which helps us because the project is fully built within a Docker container. It's great for running things super fast, and we don't have to give you like all this setup code. And Visual Studio Code is optional. We just happen to use it because it makes our lives a little bit easier. It's very contained, so you are not required to use it. And if you get stuck with the setup, or you don't want to deal with the setup, or for whatever purpose, we do offer this killer coda. So this is a link to a online tutorial that's going to go through most of the training here. Some of this, when we get to like the Grafana stuff, that's not quite as much included in here. But basically, this will walk you through the entire training and how to do the setup, and it basically walks you through it. This is also great if you want to come back to this later. We also will be giving you the GitHub project, which again walks you through it, but this is a little bit more in-depth. It is meant to be a tutorial. Just one thing to note for those of you using Killer Coda, unfortunately, it does max out for an hour for your account. We've wanted to pay them money so we could give everyone upgraded accounts during a workshop, but it just hasn't worked out for us. So just be aware, worst case scenario, you can kind of go back and just re-go through all the steps. It allows you to do that. It's not a super huge deal, but it is just something to be aware of. So let's go ahead and get started on setting up the edge. So when it comes to our environment setup for preparing, so what we normally suggest is that you go ahead and git clone this GitHub link right here. This is the InfluxDB Roadshow training. And I'm going to leave this slide up for a couple of seconds to let everybody get started on this. Basically what this will do is this will pull down the full GitHub training, and this is also where you will find, if you want to come to this later, this is where you will find it. From there, we're going to end up with InfluxDB open source, Telegraf, our emergency generators, which basically is going to create fake emergency generator data for us, and Mosquito as well. So basically, once you get this cloned, you just want to run docker compose up/d, and that will get your Docker up and running.
Any troubles? Let me know. I'll jump around with you.
The D is to shorten in Docker, right?
It's detached, so
Yeah.
logs.
Yeah. So by doing the /d, you keep it so it's more clean in your terminal, basically. There's not as much noise. I was trying to remember what that one stood for.
Anonymous sign-in.
That's right. There we go. There's your computers.
We will cover a bit of theory stuff as well, so it's not all of us if you don't have a laptop. So and Zoe will like tutorial some of it as well, so you can see it in action. It's just this bit we've done already.
I do. Okay, cool. How do you do that? Yeah. How did you? Ah, okay, cool. So for those of you guys who don't have a laptop in front of you, this is what the project ends up looking like in Visual Studio. As you can see, we have our folders here. We've got the generator simulator, which I mentioned before, Grafana, which is basically just loading in the Grafana open source version, Telegraf, Mosquito, InfluxDB/data, basically. And then if you actually run down here, if you wrote Docker compose up, whoop, yeah, up, that should go ahead and run because I'm pretty sure Docker is already running. Yeah, it's ready to go. Let's see. Again, this is one of those things that Visual Studio Code makes a little bit easier to see, basically. There it goes. Yeah, so it's already starting to create. Now, one thing to note is if you've never run this command before, like obviously this has already been installed on this laptop, but it might take a little bit of time as it has to get everything started and possibly even download it as well. But this is what we would normally expect. If you, like I said, if you don't add the /d, you'll end up with a very long list of logs. But yeah, as you can see up here, we've got all of our containers running. That's what we expect in the end. One thing to also note about this project that's really nice is we include what we call our scratchpad.txt. This will have all of the commands within our slide deck here and available for you to copy and paste. This is not because we do not think you guys are capable of doing it, but because sometimes, slashes end up in weird places or spaces, and some of these are actually quite long to write out. So you can also find the Docker compose up /d right here as well in the Scratchpad. We're also going to be saving tokens as well, and this helps you because we ask, like right here, we say the right token, for example. So that way then you save it, because for security purposes, all tokens are inaccessible once they're relatively created kind of deal. So it's just better to write them down and copy and paste them when you get them. And then 3. Yes. All right, I'm just going to do a quick progress check. How is everyone feeling across the room? We're all feeling good. We've got what we need. All right, not seeing any thumbs down. And again, if you need any help, just raise your hand. We're still here. All right, so the InfluxDB CLI is the command line interface. It basically is a client for the HTTP API, allowing you to manage many aspects of your InfluxDB instance. Let's see if I cannot zoom in here, but basically what this will allow us to do in particular is we'll be able to see our auth list. We can do things like create organizations, and specifically for us, we're actually going to use this to create buckets and to write data. So these are just a few of the commands that you can use. So what you're going to need to do now is set up a connection config and generate a new token. So I'm going to go ahead and go into that. So to connect to the CLI, these are the commands that you're going to use within your terminal. So again, within our Scratchpad, we include this command here. Just wanted to highlight that. But basically what this is going to do is it's going to create a new config called training edge. It's going to set the host URL to our local host, because again, we are running the open source Influx, so we're going to run it locally. We're creating the organization called Influx Roadshow, and we're going to be creating a brand new token called edge to go along with it. And we're setting it to active because obviously we want our config to be active. We do not want it to be inactive. That would be very bad. Yes. And basically what you'll expect, I'll try to make this a bit bigger here. There we go. Yeah, that's much better to be able to see. So what you'll expect to see after you run this command is it will give it back to you, and it will have a little star under the active. It will say the name, training edge, which we gave it, the URL that we're expecting it to run on for 8086, and Influx Roadshow. Now, obviously, I'm expecting most people here are running from, I'm going to call it a clean laptop instance, but if you do have something else running on localhost 8086, I do believe you could change it to like 87 or something, and it shouldn't be a big deal. All right, and once we've connected up to the CLI and got that all going, now we're going to go ahead and run these 4 commands. We're going to do influx bucket list, which will give us a list of our buckets. We're going to do an influx auth create write bucket with inserting the bucket ID of the bucket generator. So I'll actually just show this. We'll take it step by step. So when we do influx bucket list, which again can be found within the Scratchpad, we will see all of these buckets. So we will see monitoring, task, and generators. So generator is the one we actually created when we ran this command before, where we created all of our, for our instance, the roadshow. So generators is where we're going to store all of our local generator data. Pretty straightforward. Buckets are just another word for DBs, just a FYI. And then monitoring and task are more for internal. It's basically something that Influx can use. We use it more in the cloud than we do locally, though some of our people, when they run it locally, they use these to just keep track of what's running, basically. It's just internal data. So you would never write personally to the monitoring and task bucket. But we are going to write to the generator bucket. So specifically what we are grabbing from here is the ID. So the ID will look like a bunch of gibberish, and it will be the first one, not the organization ID. It will be very much unique. It'll be the third one down most likely, because generator should be the third bucket. And what you can do is you can insert it right there where it says to influx auth create write bucket, insert bucket ID. You're going to go ahead and pop that in. Again, this is why we have the Scratchpad to make this a little bit easier. We're going to go ahead and copy and paste that. And let me make this, again, just a little bit bigger. This gets a little weird now because it's kind of like jumbling itself a bit. But basically what we're doing here is we're creating a token that allows us to write to the bucket. Specifically only to this bucket, though. That is one thing to note. We do not suggest that you make tokens that can read and write to all your buckets for security purposes. And this one is only for writing, not for reading. So if in the future you tried to query data back out of this local bucket, it wouldn't work because you didn't yet give it the token permissions. Now, obviously, you can do that, but so one thing to know is I'm going to make this just a little smaller so it's a little easier to read for all of us, actually. So we have an ID, a description, which is kind of getting shoved down here, and then the token. And you'll be able to recognize the token because it will have double equals at the end. And honestly, it will also just be like the longest thing here. It'll be really obvious. And from that, you're going to want to add that write token on step 5. So I'm going to go ahead and copy mine here. Yeah, there we go. So yes, do take note of your newly created token. As I said before, once you've created a token, now obviously I can go back to the CLI, I can see the commands I've run, and I can grab my token again for the purpose of today. But when I close down my Visual Studio, I'll never get that token again, and that is again for security purposes. So do, keep track of it. But going forward, if you use this in a more realistic environment, don't write your tokens down in a Scratchpad notepad. That probably would not be ideal for security purposes. And then finally, we're going to run the influx auth list. Whoop. Yeah. There we go. Got to get used to the 3 swipe here. Oh, did I put that token in the wrong spot? No, I think our Scratchpad might just be. Okay, cool. Okay. And then, yeah, when you do the auth list, you'll receive basically all the information about the tokens that you have created. It's a little hard to read here, I'm not going to lie, but basically it says all of the credentials that it could have on it, which ones it does. But the big thing is that you will be able to get this token back right there. Oop. And yeah, this is our progress check. So if everyone's feeling pretty good. Which one? 7th? So just take note of your newly created token. So you're going to want to copy and paste this into the Scratchpad. So yeah, most tokens will have a double equals at the end. Everyone else feeling pretty good? We're in a good spot. I see people looking at laptops, looking up. All right. Good deal. So I'm going to really quick turn my sound off and give this over to Jay.
Testing, 1, 2, 3. Can we all hear me? Live and well? Thank you. Fantastic. Right, this is quite a long workshop, so we have time to chill and take a break. Are we all up to scratch before we sort of move on to data collection? Are we all happy? We all want to keep you up to date and keep you progressing, so let me know. Okay, so hands up. Who has heard of Telegraf before? 1. This is good. Okay, this is great because I love preaching Telegraf to a new audience. So I'm going to indoctrinate you all into the love of Telegraf. So who has heard of Prometheus before? Okay, a few more people with Prometheus. So Telegraf, you can imagine Telegraf like a Prometheus. It is a data collection tool that basically allows us to have a series of plugins that collects time series specific data and sends them to a variety of output locations. In this case, we're going to be using Telegraf to connect to our MQTT broker. We're going to be collecting data from a topic, and we're going to be writing that directly to our InfluxDB OSS instance. So I'm personally a developer advocate for Telegraf. I try and handle our community. We have a series of maintainers who deliver all of these plugins. Telegraf is completely open source to the point that we accept plugins even from our competitors. So you have output plugins for InfluxDB, Timescale, ClickHouse, MongoDB. There are plenty of plugins depending on where you want to write your data to. We're going to write our data to InfluxDB, but just to let you know in that sense. Telegraf specifically has different verticals that it has data collection abilities in. We're specifically looking at the IoT-based plugins. So we have IoT-based plugins in MQTT, Kafka, OPCUA, Modbus, HTTP, the list goes on. So the one thing to know about the Telegraf agent is it's a single binary, completely written in Go, and it's all configuration based. So basically all the plugins are compiled inside Telegraf, and you decide which plugins that you want to use based on a YAML config. And kind of the agent works in this way. We have input plugins to start. These input plugins collect from a variety of sources. You can have many of the same input plugin. We kind of recommend it for sort of parallelization of agents across the board. Data is then converted or passed through something like GJSON, through a CSV parser, through XML. We have quite a few parsers that you can basically pass our data into the agent with. We then trickle our data through a series of processor plugins and aggregators. You don't need to do processors or aggregators. They're there as an option. We just allow you to enrich your data before it reaches its final destination. And then lastly, we have output-based plugins. So in this case, we're going to be using InfluxDB. Now, the cool thing with output-based plugins is there's also serializers. So if you expect a certain output with your application, say if you wanted to send your data to, say, a REST endpoint as in expecting a certain JSON structure, we can use a JSON serializer to convert that data to the payload that you want and send that to your REST server if that's what you're going to do with the data that you're collecting. In this case, since InfluxDB is a first-served customer or a first-class customer to Telegraf, all of the data that's being processed by Telegraf is in line protocol as it goes through the pipeline. So when it comes out on the other end, on the output, it's all in line protocol, so we don't actually need to use a serializer to change it to any other format. So just a word on that one, that's why we're not using a serializer. In our case, for MQTT, it's all coming in as JSON, so we're going to use the GJSON parser to parse the data that we want out of our JSON payload, convert that to line protocol, and push that through our Telegraf agent. Any questions on that one? Any sort of... Just an FYI, if you're a hardcore Telegraf user and you hate the binary size, you can build a much smaller binary size. We do offer tools for that. We do have customers that are putting them on Telegraf on robots to monitor their basically these house robots that go around, so we can reduce the binary size quite considerably. Okay, so the plan for Telegraf, we're going to connect Telegraf to the MQTT endpoint. This is the payload that we're going to be dealing with, very simple payload, but essentially we're going to have a generator ID, which will become important when we pass it into InfluxDB. We're going to have a lat and long, which will be important again later when we start to visualize our data. And then we have a series of sensor values. In this case, very basic, temperature, power, load, and fuel. What you'll realize based on this simulator that we've created is the load governs the temperature, power, temperature, power, and fuel. These fluctuate based on the load level, and then the load level is randomized throughout. So just a basic simulator. And then as we said before, we're going to have Telegraf with our MQTT collector, pass it with GJSON, and then output it to InfluxDB. All sound good? Sweet. Okay, so the first thing that we're going to do is we're going to open our Telegraf config. So you can find our Telegraf config at the directory Telegraf and then telegraf.conf. And this is a YAML file that contains how you want to utilize the plugins within Telegraf. The first thing that we're going to look at is the MQTT consumer. Now, can anyone tell me, oh, I shouldn't have this up here. Has anyone read this? Can anyone tell me why this hash on topics is bad practice? Correct. Ta-da, there it is. So the thing is, you know, in a very small use case like this, we have only 3 topics. We have a parent topic and 3 child topics that we're sending data to. In a real world use case, you could have 1,000 different topics or plus, all doing different things for critical solutions. Now, MQTT has a variety of ways of securing different topics and making sure you can't subscribe to everything. But as a rule of thumb, you should really only subscribe to the topics that you want to collect data from. Hash, which is a wildcard, which allows you to basically collect from anything, is still a usable symbol, and we will still use this as we go down our config. But as a rule of thumb, unless you really need to, you shouldn't be collecting from every single topic that there is in your MQTT broker. Apart from this, what we'll do is we'll sort out that topic part here, and we will also add some JSON parsing as well. Let me know if anyone else wants any more information on any of the other config parameters here. Essentially, we just have our server here. We're connecting to our MQTT local host that we're running. It's just a Mosquito broker that we've installed as a Docker container. And then we're running on COS2. Connection time at 30 seconds, and we're defining our data format as JSON v2. So, the things that we're going to change is we're going to use a topic called emergency generator, and we're still going to use that hash because, as you saw before, basically what each generator is doing is writing underneath that parent emergency generator under their own unique ID. So each generator has generator 1, generator 2, generator 3, and so we want to subscribe to all of those child topics under that generator. So that's what we're doing there. The next thing that we're going to do is, if we remembered, we actually have this lovely payload here. Now, can anyone decide what would we consider a unique identifier within this payload? What would we do to distinguish one generator from another? Which of one of these would we use? Correct, yeah. The idea for us, especially in a time series database, is, boom, I know, sorry, you should have much more complicated. He's like level 100, okay? You know, like, but the idea within a time series database is, as well as having a timestamp, you also have a good index as well. And this allows us to distinguish from one sensor to another. So you may have plenty of these different distinguishing markers. In this instance, it is a very deliberate, we're going to use generator ID, but people use anything from OPCUA tags to the actual topic names as tags to differentiate your different series and what those sensors are producing. But A star over there, sock for him. So, as we can see here, what we're doing is we're transforming our payload or passing our payload a little bit before it goes into line protocol. For now, we're given a static name, measurement name called gen data. This will be the table that we collect our data into. What we're actually going to do is we're going to pass our object. So basically what we're doing is we're collecting a path from our JSON field here. We're saying, give me that root directory of our payload. And what I want you to do is I want you to transform the generator ID into a tag. The cool thing about path is this is basically a very simple version of just collecting data at the top level, but you can basically use this as a pathway in JSON to collect at different root levels of your JSON payload. So we have people that basically will have a lot of nested JSON structures. If you've ever used something like the Things network, that's a big one that has a huge nested data structure. You can use GJSON to basically filter through, find a certain device ID, use that as a tag, or transform some values. So JSON v2 is a great parser, and it's all Go based, so it's quite generic and keeps getting updated. Okay, so before I move on any further, let's do this in practice. So if I jump into my Telegraf config, so I have my directory here, and you can see I have my Telegraf config. So just some stuff to note in the Telegraf config. You have an agent. Normally, if you think about the Prometheus world, it's like a collection agent, so we could collect, say, every 5 seconds or based on time. The cool thing about the MQTT consumer is it's obviously event-based. You basically, anytime a topic, like anytime a sample gets pushed to a topic, you're expected to pick that up by your MQTT who's subscribing to that topic. So Telegraf can act both as an event consumer and also as an interval collector. So if I scroll down to the bottom, and you see we have our MQTT consumer here. If I jump into our Scratchpad, you can see that we have our topic here. I'm going to copy and paste this one in. This is part of step 6. I'm going to chuck this one in here. And then I'm going to jump back up. So we've sorted out our topic. Now, what's going to happen is we've done none of our JSON parsing at this point. So if I just simply ran this Telegraf config, we're going to have all of the data go through to InfluxDB just as a bunch of fields. And what will happen is because they will all share the same timestamp, we'll basically overwrite data in InfluxDB. So generator 1 will overwrite generator 2 will overwrite generator 1, and generator 3 will overwrite generator 1. It just depends who's there first or last. So in order to do that, we're going to then do our field parsing. So if I jump back to our Scratchpad, copy and paste our input MQTT consumer here, I'm just going to paste this just below. And essentially, as you can see here, we basically reference our MQTT consumer plugin. We say that's our parser based on the data format, and that's where we start adding our options underneath as part of the YAML file. Give that a save. Any questions so far? No? Cool. So we've basically sorted out our input plugin. We're just about ready to start collecting data. The last thing that we need to do is finish provisioning our InfluxDB v2 plugin. There's not too much to do here. We're basically just going to take that token that we created earlier, and we're going to place that inside the token field. Now, this is not security best practices. I recommend using, like, say, a Docker secrets file, and then including these within this token parameter here. We can accept environment variables and Docker secrets. This is purely just to get you guys going and get it going quick. So we're just going to copy and paste the string literal token into the config. But yeah, not security best practices for this workshop. I think we're both security conscious since we went and saw that workshop, that other talk.
Also, if you do this on GitHub later on your own time, please do not upload that file with your token in it. Don't do it.
So we'll copy and paste that right token Zoe created earlier. We'll jump up in our Telegraf config to output.influxdb underscore v2. And we'll paste that in there. So now you can save the file, and that is our Telegraf config ready to go. The last thing that we're going to do is we're going to restart the Telegraf container. This will pick up the new config and allow us to start collecting data. So here's the Docker container command. If you have on Visual Studio Code, like I do, Docker available, you can just restart it directly from here. If not, you can jump into the Scratchpad, and we do have the command available for you there. So you just have the Docker container restart. Now you don't need to do this, but I'll just show you what the logs look like so you can see. You can basically see that our Telegraf config has started up successfully. It's connected to our InfluxDB v2, and it's also connected to our MQTT broker. And you can see that it's wrote metrics as well based upon that as well. So Telegraf inherently has a buffer. It's an in-memory buffer. So for whatever reason, if you do have a connection outage, basically metrics will fall into the buffer. If the buffer, you can gauge how big you want your buffer to be, but if the buffer is exceeded, then we start dropping metrics in this case. So this will just be the distinguisher from why we don't use Telegraf as our direct way of writing to the cloud. Telegraf is only durable on memory. InfluxDB is durable on disk, and that's how edge data replication works, which Zoe will explain earlier. But that's just why we don't use Telegraf in this instance if we want a truly hybrid durable system. Okay, so the way that we can check that data is definitely being written to InfluxDB is we can run a command on the command line. We can do influx query, and essentially what we're doing here is say, give me all the data from the last hour from the bucket generators. So I'm just going to clear this so you've got a better view. If I run this, you can start seeing that we're starting to write our data through. We have generator 3, we have our data there, we have our time stamp when that came through, and it's our temperature field that we're seeing there. I think I'll scroll up a bit, you might see a bit more. Go. Okay, how are we getting on? Good? Good? Yeah, no worries. I'll jump back so you can just see if there's any of those commands you missed. So just while we're waiting, just see if everyone catches up. What you can do also, instead of just doing the CLI as well, is you can actually use the UI on your InfluxDB OSS. So if you just go to localhost with the port 8086, you can go to the data browser and you can have a look at your data there. As you can see, we have our different fields that we were writing in, and then we have that generator ID, which is now considered a tag, which is our unique series. And if I swap over to the table view, you can see what that looks like rather than being in a graph.
Short question.
Yeah? Oh, sorry, demo user. Yeah, sorry, I don't normally go into the OSS CLI, but demo user, one word. Yeah, demo user, demo user. Yeah, bad practice again, but right, how are we all doing? Doing okay? We good? Dabby dozy. Right. I think. Well, my watch has ended. I will pass back to Zoe, and I'll see you guys later on. I'll be here as the helpful assistant once again.
Great. Yeah, there we go. Long hair. All right, so we're going to go ahead and work on downsampling and edge data replication. All right, so the plan here is that we're going to use our InfluxDB Cloud accounts. We're going to make a new bucket that will accept our data. It's going to be called Northbound. I just got it up there. It's very nice. Aggregate the generated data to a new bucket called downsampled, which is going to be on the InfluxDB OSS. We're going to we're going to use Flux, which I'll get into, but basically with that, we're going to create a smaller version of our generator data because it's going to be sending us data about every second or so, but we don't really need it that finite. We can get with about a minute or so, and so I'll show you how we're going to downsample that. We're going to test the output, make sure everything looks good, and then finally we're going to send the data to our InfluxDB Cloud using edge data replication. So first things first is we're going to make that new downsampled bucket that's going to be on the OSS. So this one's pretty straightforward. We're going to do influx bucket create. We're going to name it downsampled. And then we're going to check to make sure it's available within the influx bucket list. So let me go ahead in here and grab this. And that -R2D means retention policy 2 days. So basically what we're saying there is we don't want the downsample bucket to hold the data for more than 2 days. We didn't put a retention policy on the original generator's data, at least not with the CLI. We might have put it in the, yeah, no, I don't think we did. So yeah, when you go ahead and create your bucket, you're going to, here, I'm going to make this big again, and I'm going to make this go away. There we go. Perfect. So you're going to go ahead and see that it's got a name downsampled. Actually going to see the retention policy, which for here is 48 hours. The shard group duration, which is 24, and then the organization ID, which we would expect it to be the same organization ID as before because we haven't moved orgs or anything like that. And then as I said before, the next one after this is going to be influx bucket list. That will show us a list of all of our buckets. We ran this a bit earlier. Oh, whoops, my bad. Yeah. I think I like accident. Control C. There we go. Cool, there we go. So yeah, now we can go ahead and see that generator is actually 24 hours. So yeah, this one has a slightly longer retention policy with 2 days versus 1. And the shard group duration is only 1 hour on that one. But yeah, so we should expect to see a downsample bucket when we run this command. So now we're going to create actually we've already created this, so you guys won't have to worry about it. It's already created within the Docker file system. It's called our downsampling task. So the reason that we don't have you create this from scratch is pretty straightforward. It's that right now what you guys have downloaded on your computers is InfluxDB OSS version 2. That's the version that we have. That's the latest. At the end of this year, early next year, we'll have V3, which will no longer be using Flux as its main language. V2, though, does use Flux, and so that's what we've used here to downsample. We're going to have this kind of downsampling capabilities eventually within V3 as well. You can still do some of it right now, just not all of it. But basically what this does for us is it says our range to start basically from bucket of generators. We would like to range of last success, which is a cool function that basically returns the timestamp of the last successful task that ran, or time of the past hour. Basically, in the past hour, can we go ahead and get all the data from the generator bucket? And I would like to aggregate this down to every 1 minute, give me the average, basically. And from that, we want to send this onward to the bucket downsampled. So as I said before, and this is pretty common within the IoT world, you're going to end up with sensors that give you data every second. And you might say, well, just make the sensor send you less data, but that's not how this works. They're built the way they are, and they just send it to you. And sometimes it's even nanoseconds. And now, in all fairness, a lot of people do prefer that precision data. You know, it's very useful. But sometimes, like in this example, we don't need it down to the precision. We can handle getting the average for the minute. We don't need to know the temperature every second or even the fuel value every second. And the other thing to note, where this really becomes important and actually very helpful, is after you're done monitoring your data for the day. Like you're monitoring an actual factory floor, the day ends, nothing crazy happened, but you still kind of want to keep your data. You kind of want to know normalcy, especially for looking for anomaly detection later on. You'll downsample it so then you don't have to store as much of that data. Because if you have a data point every second, in an hour you're going to have, I think, 100,000. In a day, you're definitely going to have close to 1 million data points. And although it seems pretty small, the data's not that much on this. It's just fuel and temperature. Some of these get quite large. You could have like 100 fields. And so with that, you kind of want to start to aggregate it down, make it smaller and easier to manage, and obviously very much cost effective. Very important for everybody. So this is already created. You're going to see it within the file system up here, I believe. Let's see where it is. Yeah, it's living within the Flux file. But yes, that's basically what it's up to for us. So that's why this is called our downsampled bucket, is because we're downsampling our bucket here. So one thing you're going to do is you're going to run influx task create, and then you're going to basically call this file. And what that will do is that will create the task. I guess one thing I didn't quite explain when I did this. Oh, sorry, my bad. One thing I didn't quite mention here. The task here, that's what we're naming this. This is the actual, sorry guys, I missed this. The task is named downsampled. It runs every minute with an offset of 5 seconds, just in case some of our data is lagging to come in. It's very common to have an offset on a task. But basically what we're going to do is we're going to have Influx create this task, and we're going to tell it that this is the task that you're going to run, which is our downsample flux. And again, that will be within your Scratchpad. It will be step 12. All right, and when we do that, you'll receive this back, which will basically tell you that the task is running, and it will say that the status is active, it's running every 1 minute. It says the organization it belongs to, which for us is Influx Roadshow, and the name, which is downsample. Oh, yes, that's right. One more, thank you. Let's see here. Sorry, I'm trying to remember. Oh, there it is. Yes, so in the UI, if you click on this little, is this one right? Yeah. If you click on the little bell over here, one up. Oh, sorry, the calendar. If you click within the calendar right there, you'll be able to actually see your downsample task here. And you would be able to see if it ran. But currently it hasn't been a minute, so that's why it hasn't run, in case you're curious. I moved a little bit too quickly. I've beat it to the punch. There we go. Much better. If I just wait a couple seconds, we'll actually get to see it running. So as you can see, it started, it's scheduled, it's going. So now our downsampled bucket, we would expect to have some downsampled data. Unfortunately, I don't think we're going to get, oh, that's right. Yeah, we won't be seeing it here. All right, let me go one more back here. Cool, so edge data replication. So edge data replication is a feature that Influx has within it. You can do this between two OSS instances. So you can go from InfluxDB OSS to another InfluxDB OSS. Obviously, the more common is to go from InfluxDB OSS to InfluxDB Cloud. Now, one thing to note that's special about edge to cloud replication is that it has a disk back queue. Basically, it does have limits. You can't store everything in there forever and ever, but basically, if you have a power outage of a couple hours or possibly even a couple days, it will store it in the replication queue. Again, this is where having a downsampled amount of data can also be helpful. Your disk back queue will go a lot farther if it doesn't have to store as much minute data. Now, obviously, again, like I said before, for a lot of people, you do need the minute data, and that is why it has a disk back queue. Online, you can find more information about the limits, but basically what it will do is it will create a connection between the cloud and the InfluxDB OSS, and it will know when the data has made it into the cloud, so it also will not overwrite your data. And it will go back and delete what has gone away. So this is also good for people who expect intermittent outages. For example, we have a company that monitors solar panels within Africa. They are actually in remote villages, very similar to our use case here, and they do expect power outages, or actually more what they're expecting is that as the satellites that they get Wi-Fi from roam the earth, they come back over the panels at certain points during the day, then they disappear, then they come back around the next day, and they use edge data replication to store it as they know on their edge devices, their solar panels. I think they have a server or something there. And every single day it goes up to the cloud, and every single day the disk back queue is empty and deleted as it sends it on up, and they can monitor it from afar. So what I've just described here, one was direct replication. That would be if we just went straight from the generator data. From what I understand, that client does this. They're just doing it directly. Pre-process replication, like I said, can help you out along the way. And do keep in mind, a lot of people do a combo of these for backup purposes as well. If you're, like I said, we don't commonly think of power outages or internet outages, but when it happens, it's the absolute worst thing normally. Like if you really weren't expecting it to happen, that means it's even more important to have backup plans and be prepared in case it ever does. So yes, for some of our clients, they'd most definitely do both of these in a combination. And just to note, for this project, you could have also done that as well. We didn't have to do the pre-processing. So now we're going to create our InfluxDB Cloud bucket. So when you go ahead and go to your InfluxDB Cloud account, so that's not, it's not going to be the one on localhost. I'm just going to walk through it on here. So you're going to go to, sorry, not sources. You're going to go to buckets. You're going to go over here to the create bucket. And we're going to go ahead and give our bucket the name of northbound. So right there, northbound. This is a little, I'm realizing how small this looks, so I'm going to actually put this, and we're going to do a retention policy of 30 days, so nothing crazy. Here, let me see if I can. Yeah, there we go.
So just to level set the room, just to make sure it's all clear. So Zoe's jumped into our cloud instance now rather than the edge UI.
Yeah, so make sure that for you guys, you'll probably see EU Central or West or East. I always see West because I'm in the US, but make sure you're not seeing localhost. This should be within your cloud account. And yeah, it's going to be called northbound bucket. If you name your bucket something else, you'll have to configure things, and it's just easier if we all name it all the same. Then you're going to go ahead and create that. And then from there, we're going to create a new token for our bucket. So going back into the UI, you go up here to API tokens. Now this time we're doing this instead of through the CLI, we're actually doing it through the UI, so I can talk about this. This is what we don't suggest you do, which is an all-access API token. It will even warn you to not do this. For this project, yes, you could, I suppose, because you just have one little bucket to deal with. But normally what you'll do is you'll do a custom API token. You'll pull up all of your buckets. And we are going to go find our northbound bucket. And we are going to set it for writing. I think, actually, is it set for read as well?
Yeah, because I need it.
Yeah, that's right. So we're going to do both read and write. It's about to say, I think, yes. So make sure you've got both clicked, ready to go. And then I'm going to make this a little smaller so I can see the button. And then you're just going to, you want to describe this new token. So when we did it, we just called it edge_2_cloud_generator. So let me go ahead and go back and write that out so it's a little easier to see. Is it generator or replication? Yeah, that's what I thought. All right, I'm going to make that big again, just that way then people can read it. So yeah, you're going to want to make sure to call it. I actually don't think, it's not required that you call it that, right? You can actually call it whatever you want.
Yeah, it's just
Yeah, that's what I thought. You can call this whatever you want. I'm making it big so you guys can follow along. The big things are just make sure your northbound bucket has that read and write. That's the most important thing here. All right, and then I'm going to go ahead and click the generate. You will see you've got a new token. Right here, this warning. Make sure to copy your new custom API token right now. You won't be able to see it again. Please do not close this until you have copied it and made sure that you've copied it. I mean, I'm making it sound like it's such a big deal, but to be honest, you could just create another token. But, you know, make your life easier. Go ahead and add it into, right here. Go ahead and add it into your Scratchpad. You're also going to want to grab your northbound bucket ID. I'll show you guys where to get that. But just again, make sure to grab this. I mean, again, worst case scenario, you just have a bunch of tokens. I know personally I'm very guilty of it. I have like 20. I don't even know what they do. This is why writing a good description is important. And then when you're on your buckets list again, you will see, one second here, there it is. You'll see northbound. It will have an ID right here. It will even come up with copy to clipboard. If you just go ahead and click on it, it'll go ahead and copy it to your clipboard. Make it really straightforward, and then you'll just add it to your Scratchpad. Everyone feeling good? I think so. So also one quick thing to note here, I noticed this earlier. One thing you guys might want to grab is your remote URL and add it to your Scratchpad. It won't be here, but I think you should do it because we might have to edit the this command here. Yeah. Yeah. I'm just going to grab it really quick because I already have it up. But I did notice that even yours is not technically the, you can tell who wrote this Scratchpad. Yeah, there we go. I'm just going to save that for myself. All right, so we're going to go ahead and also save the downsampled ID. So again, we're going to look at the Influx bucket list. So we're going back into the terminal. We're going back to look at our open source. And this was such a most recent command. I already know it's hanging out there. So again, you're just going to want to grab your downsampled ID. So this is not your organization ID. It's going to be right there. It most likely will either be your third or fourth bucket. And you're going to put it in step 15 in your Scratchpad. So your Scratchpad should look something like this. It should have, step 14 should have your northbound bucket ID and your northbound bucket token, and then your step 15 should have your downsampled bucket ID. That's what we would expect your Scratchpad to look like. Okay? Good deal. The next thing we're going to start doing now is the commands for actually creating our remote instance. So we're going to do influx remote create. We're going to give it all of our cloud credentials. This is basically saying that this is the cloud account that we wish for our remote connection to go to. So again, just do keep in mind, in the Scratchpad you will see this. It will ask you to put in your org ID and your cloud token that we just grabbed earlier. Just do keep in mind that you guys might have to change that remote URL. It's currently set for US East. I'm changing it, for example, to be AWS EU Central. So right in here, you'll see it in step 16. I'm going to go ahead and fill this out. Oh, whoops, my bad. But wait.
That one's your cloud org.
My bad.
Sorry, that's your bucket ID, your cloud org ID.
Ah, my bad. Sorry, guys, I'm getting myself confused. So to get your org ID, it's going to be right up here in the URL. You can find it elsewhere in the UI, but this is going to be the fastest, is right here. It'll be, you'll see /org/ basically this token. That's your org ID for your cloud account. There we go. Wait, this should be, Am I getting, yeah, okay. Yeah. Okay, and then you're going to go ahead and put in your token that you got from your cloud account. And then you're going to grab this whole command here and go ahead and pop it into the terminal. Awesome. And it should throw you back basically saying that this is your first remote connection. It will have an ID. It will say, here, let me make this a little smaller so it's a little easier to read again, for me at least. It'll have a name. For this one, it's called Cloud. It has the org ID attached to it, the remote URL. Basically, it's just giving you everything back that you just fed it.
Does anyone need us to go over where we collected that? There's a lot of chopping and changing. Does anyone need to know where any of that stuff came from?
Yeah, sorry guys, sorry, there's a lot of copy and pasting right here.
This is probably the peak hard complexity that this is going to give you, so don't worry too much after this. Yes.
Yes. Yeah, so yes, just to clarify, org ID right up there at the top, that'll be the first one for this command that you grab. Whoop. And then the next one, we're actually going to start now creating the replication. So with that, we're going to need our local bucket ID, our remote bucket ID, our remote ID, and we're going to go ahead and name it edge to cloud. So again, you're just going to go ahead and pop in all of those variables that we already have saved in the Scratchpad. This one.
So sorry, I'll just speak through Zoe's mic really quickly. So just a bit of context through how no worries, you're so good. Through the remote, how this is looking. So we have basically two instances. So we have our remote. This remote is basically your connection credentials to your remote instance. From there, what we will do is we can create replication queues for that remote instance. So basically, that remote instance gives us the credentials for all of our other replication queues, so we don't have to provide a token and an org and a URL every time we want to create a new replication queue. That's kind of the way we're going for. Correct, yes.
And this is the remote ID right here. That's what we're grabbing for the final piece of this command. So again, your local bucket ID, that's the downsample that you're going to find in step 15. Your remote bucket ID, that's going to be your northbound one off your cloud account. And finally, the remote ID, which will come from here when we created that remote instance. All right, and once you go ahead and run that, you'll see here, you'll see the amount of, sorry, again, this all gets kind of weird, the amount of bytes on disk, the max queue bytes, last status code. There's all kinds of great stuff here, but it will also repeat things like your local bucket ID, the remote bucket ID, the name, etc. Again, this is there's a lot of information on the command line here. I've kind of got this a little big to make it easier to read. But what you can also do is you can run the influx replication list, and that will repeat what we just created. So obviously with this one, we're just doing one quick replication. We're just sending it up to our northbound bucket, but obviously you could set this up to run to multiple cloud buckets as well as sending different types of local buckets as well, obviously. So this is kind of will just show us the whole list if we had multiple. So we're going to do a quick progress check. How is everybody feeling so far? Seems like most people are getting help when they need it. Yeah.
So, Influx Remote Create. This is essentially where we're creating our connection details for our cloud instance. If you jump back into our cloud zone,
Yep.
Our remote URL comes from here. We also need our remote org ID. This is our cloud instance that we're connecting to. As you can see directly after orgs, this is our remote org ID here. It's basically just our cloud org ID. What Zoe also collected was an API token. So this API token was one we generated, which was giving us write access to our cloud bucket. So all Zoe did was custom API token. In this case, she selected the bucket from the list. She gave it read and write access just down to the point that I need the token later for when we're creating our dashboards. She clicked save, and that gave us our token. And then so we used all three of those to form our remote instance. Now, you can have many replications queues to one remote instance. So imagine, say, you have 10 buckets, all collecting different types of data. You only need one remote instance. You can spawn, say, 10 different replication queues from that remote instance, and that basically inherits all of those connection credentials into those replication queues. You can, of course, have as many remote instances as you want. Say you might be writing to one cloud, and to another cloud, and to another OSS instance. It just adds that modularity to those. That's why we don't try and force you to write all those connection credentials in every time that you create a replication queue. Does that make a little bit more sense? Raise your hand if you're struggling with any of because I'd say this is probably the peak of like having to make sure we've collected things from all over the spot. Does everyone know where we got the local bucket ID and the remote bucket ID from? We all good there? So, if you want to swap back over to VS Code.
Yeah.
So, local bucket ID is our InfluxDB OSS instance. That's the one that's running at the edge. If you run influx bucket list, you've got a...
Oh, I probably spelled it wrong. Yep.
So you can see we have our IDs down here. We have our generator one and we have our downsampled. This ID here is for our downsample bucket. This is our local bucket ID. This is where we're going to be replicating our data from. Then our northbound bucket ID we collected from the cloud. You jump back to the cloud. And then jump into buckets. You scroll down.
Yep.
You can see we have our northbound ID. Yeah. Here. You want to check ours is working, Zoe, before we make sure? Yeah. You want to just check the data explorer?
Oh, yes. So once you have that all set up, you can go ahead to your cloud account and you can go ahead and grab on that northbound bucket and check to make sure that there is some data coming through. So for example, select Gen Data, run. As you can see, I'm getting a table back with data included. So this is what we would expect to see in your gen. You would expect to see your generator ID, the fuel levels, your latitude and longitudes, your load, location for these ones that are in the US, etc. Let me go ahead and... One other thing to note is because we've already downsampled this data, you're going to notice that it's only sending in every minute. That is to be expected because we've downsampled the data before we send it up to cloud. If we had just sent it raw, we would be seeing a data point roughly every second. So while Jay helps him out, does anybody else have any questions or concerns? We're all feeling pretty good. All right. So we originally did have a refuel time. I realized that we still have a bit of time actually before the official coffee break here at Porto Tech Hub. We have about 30 or so minutes. So we'll go ahead and wait on the refuel as long as everyone's good. If anyone needs to use the bathroom or something, I think we're all good. So we're going to go ahead and switch to the cloud, and I'm going to give that to Jay to do. So let's give him just 1 second here. And yeah, from here, we're going to take it into Grafana and start to build out our visualizations. Now, I know you guys probably noticed that within the cloud, there is a little bit of visualization options, but we don't, but we don't normally suggest people, this is more just to be able to see your own data here, make sure that things look roughly correct. It's not really so much for graphing in the way that Grafana is. So for example, I do see my graph, and you're going to notice that the data is very erratic. The fuel is kind of all over the place. That's to be expected because, again, this is randomized data. We don't expect it to be quite formalized. That's all on purpose. So yes, you can do a little bit of graphing here, but we don't normally suggest doing a ton, and it won't save either. So right now I have this. I'm looking at it really quick, but when I leave this page here, it won't be here when I get back. So that's also another thing, is that this is not meant to be saved. I'm going to put this down here. So when Jay is all done, he'll go ahead and come up here and take this over, but I'll get us started on the cloud. So we've already kind of started on the first part, which is to use the Data Explorer to query InfluxDB Cloud. The only difference is we're going to start doing this now in Grafana. We're also going to configure it, and we're going to add what we call a basic visualization. This is basically going to be a line graph, and an advanced visualization, which we're going to be using a map tile to see where all of our fuel is located. Finally, we're going to be creating a check and alert system. All right.
Over there, which we're trying to get around. Classic Windows. Sorry, Windows. But does everyone else see data in their cloud? If not, worst comes to worst, if we can't get you seeing data in the cloud, we can just give you connection credentials to ours, and you guys can just basically do the queries and stuff from Grafana using our own cloud credentials. So, as Zoe said, we're going to have a quick look at our data in the Data Explorer. We're then going to configure Grafana using our new plugin called Flight SQL. So since we're using v3 of InfluxDB, we now have native SQL support for InfluxDB. So you can basically use time series queries with basically a Postgres style of query language that everyone's used to. We're then going to generate two visualizations, just a standard line graph, so you can see we're actually generating data in the cloud. And then we're going to do a more complex advanced visualization where we're going to map our generators onto a map, so you can basically see the fuel levels and where those generators are in the US. After that, we're then going to create a check and alert in Grafana so we can start alerting our engineers to when there might be potential faults within our when there's potentially low fuel levels within our engines. Okay, so the first thing that we're going to do is we're going to jump into our data explorer. So as Zoe pointed out, this is just a first stop call to allow you to navigate and look at your data within InfluxDB. What the Data Explorer allows you to do is it will basically give you your schema for that bucket. It will generate some of the SQL on your behalf and allow you to run a query. You can either see that query as a table, or you can also do a basic line graph within the visualization there, just so you can see what your data looks like. So we'll quickly do that now, and we'll have a check to make sure our data is actually being replicated from edge to cloud. So I'm just going to get rid of this VS Code because we're not going to need this for the time being. It just makes it easier chopping between slides like so. So as you can see here, we have our schema browser on one side and we have a list of buckets. So these are all my buckets that I have as part of our cloud instance. Essentially what we're going to do is we're going to scroll down to northbound. What it will do is auto-generate the measurements. As you can see, we have gen data there. So this gen data contained all of our generator data and all of that, basically all of the generators, including our fuel, load, and temperature. So I can select this measurement here. And then this will cascade into our fields and tags. Now notice that we have our fields from before, our lat, long, load, power, fuel. These are all our numerical values which contain our sensor readings. And then we have our series of tag values. Now notice that we have our generator ID tag value that we created ourselves. So I feel I'm getting a bit loud. But we also have a few tags that we picked up along the way as well. So we also have host, location, and topic. So if we remember our MQTT topic, that is now considered automatically a tag. So if we load that, you can see we actually have our three tags here. We have generator 1, generator 2, and generator 3, all underneath that parent emergency generator topic. We interestingly also picked up a location topic. And now a keen eye would have found out why we picked up that location topic. And we actually added that within our Flux task. We enriched our data by adding a new column and basically specifying where the location of our generators are. So just FYI on where that tag came from. Host is just something that we're going to get directly from InfluxDB. So because we're running InfluxDB in a container, this is our container ID here. And this is just auto-generated when we write data up from the replication queue. So you always know which InfluxDB OSS instance is writing the data to your remote instance. So it gives you a way of filtering between all those remote instances. I shouldn't tell you this, but some people use it in OSS to make a highly durable version of OSS, since all the high availability is left to enterprise, but that's how people do it. And then lastly, we have, of course, our generator IDs. So as you can see at the moment, we have a select star and we have our gen data. We have basically a star here which allows us to pull all of our data, and we have a table of our data that includes all of our measurements, including generator ID as well. If we wanted to, we could basically specify just fuel. That's actually a bad way of doing it. Let me toggle this off. We could basically toggle off SQL like so, and we can specify our own SQL commands in here. So I could put fuel and time and run this, and this basically gives our fuel levels and our time, and then I can generate a graph as so. Which is basically based on the grouping. So if I say generator ID, like so. I can spell generator right. There you go. And as you can see, we've grouped by generator ID, and we have our data back that we're replicating from our OSS instance. So this is just a stopgap to show you that we're getting data in our cloud. But why don't we use something like Grafana to actually be a robust pane of glass for actually visualizing our time series data and creating a dashboard for our engineers on the shop floor that are looking at this generator data. So you've got two options here. You can either use Grafana Cloud to build your dashboard if you want to, or you can use the local OSS version of Grafana. It's completely up to you. I will use the local host version of Grafana just to get things built, but if you want to keep things around longer, then Cloud's also an option. If you're doing this on Kilocoder, then you also have the ability to click through to your local host instance of Grafana as well, but I think most people are doing it on their laptops. So. Oh, yeah, but like we won't tell them to do that yet until we built it. Yeah. So password is admin for Grafana. Just, again, super secure. But that one's not by me. That's just the default password for Grafana. Okay, so what I will do here is I will open a new tab, and I will go to localhost 3000. I will log into Grafana, and I will skip creating a new password, just for now. And this is our welcome panel to Grafana. All up to this point? Are we all okay? Yeah, sweet. So the first thing that we need to do within Grafana is connect our InfluxDB instance. And the way we do this is through a data source. So we are a first-class customer with Grafana. We have a series of data sources that work with Grafana. In this instance, because we're using v3, we're going to make use of a community plugin called Flight SQL. We are releasing this officially in our v3 plugin. But for now, we're going to make use of this community plugin called Flight SQL. So we're going to jump down to data sources, click add data source, and we're going to add Flight SQL. So I'm going to do this now. So I'll open the toggle menu, jump down to data sources, click add data source, and you'll see that there is an InfluxDB here. We're not going to use this today. We're upgrading this to v3 as we speak. We're going to type Flight SQL instead. And we're going to make use of this plugin instead, the Flight SQL plugin. Once you click that, you should see a data source config initiate like so. You can keep it called Flight SQL if you so wish to, or you can change it to InfluxDB. And we're going to start providing the connection credentials to connect to our InfluxDB Cloud instance. Everyone okay so far? Yeah? So what we're going to do is we're going to provide our host and port. Now, just for this plugin, all you need is the actual host, and you can remove the protocol from the beginning. So remove the HTTPS from the beginning. You simply just need the domain from your cloud, :443, our secure port. Our authentication type is going to be token. The reason why we give multiple authentication types is because we built this plugin to allow anyone who uses Flight SQL, such as Dreamio or DuckDB or these other databases, to be able to use this plugin themselves. This was one of our contributions back to open source. We're then going to toggle on require TLS and SSL authentication, because that's required by InfluxDB Cloud. And then we're going to provide some metadata. And this metadata is the bucket name with the value northbound. And this is how we tell the plugin which bucket to actually query our data from. So I'll do this now, and then I'll stop just to see how we're getting on. So we have our host and port to put in first. Easiest way to do this is jump back to our cloud instance, copy and paste the URL on top. It's going to give me the protocol, so make sure that you delete that. So I'm just going to delete the protocol here, make sure that's gone, like so. Remove the trailing space here, and add a :443 on to the end. Our authentication type is token. And what that will do is give us a token box here that we can basically copy and paste that token that Zoe created earlier. So that will be within our scratch pad, which I've put down. VS Code, here we go. So thank you for this, Zoe. We've got our northbound bucket token here from our scratch pad. I'm just going to copy and paste that in. If you've lost your token, do not worry, just create a new one with read privileges to that bucket in your cloud instance. Copy and paste that token in. Enable TLS/SSL. And then in our metadata, we're going to type bucket name, and we're going to type the value northbound. And then we're going to click Save and Test. And what you should see is a lovely, nice green bar that says, okay, you've got data, hopefully. Yeah, good. How are we all getting on? Thumbs up, thumbs down, okay? How's our Windows user doing? Are you doing it? You got it? Awesome. If not, we can give you our connection credentials and you can just use our data if you like, whatever works. Sweet. How are you guys getting on over here, okay? Yeah? Sorted. Okay, before we move on to creating a dashboard, what I just wanted to show you is we can actually do data browsing directly in Grafana before we create our dashboard. And so I'll quickly show you this just as an FYI. If we navigate back to home and we open our toggle again, if you click on the Explore tab, what you can do is you can actually look at your data directly from here. So we can say gen data, we can either click one of the columns from our drop down, or we can hit star. And then really we should, maybe I'm not allowed to do that. Okay, let's do fuel plus generator ID. And then really I should put a where clause of a time, but just for the purposes, we'll just do a select star. And as you can see, we bring back our fuel and our generator for that data. So just a quick show on the browser. This is their like query creator. What you can do is you can jump into edit SQL, hit switch mode, and it generates a SQL on your behalf, and you can work and start working on your SQL from there. Okay. So the first thing that we're going to do is generate a dashboard, and we're going to put in our first simple visualization, which is going to be looking at these fuel levels. So what we're going to do is, if I jump back to our slides, we're going to go on that panel again, we're going to go create new dashboard, and we're going to go add panel. So if I jump back across, go to dashboards, click new dashboard, add visualization. And what we're going to do is, since it's our first visualization, we're going to be selecting Flight SQL because that's our only data source. But you can have multiple data sources within one pane of glass with Grafana. So if I select this, we're now ready to start creating our query that we're going to use to visualize our data. So if we navigate back, what we're going to do is we're going to select time series as our first graph. We're going to give it this query here, which is going to be select time, fuel, generator ID from gen data. And now this is interesting because this is Grafana specific. So this is what we call a Grafana variable, and this is what makes their dashboards dynamic. So what this $_ time range time does is basically says, make sure you grab the current time range set by the user from the dashboard, which means if they drop down and say, I want the last 24 hours, it's going to update the where clause for the last 24 hours. If they ask for the last year's worth of data, it's going to update the where clause to make sure that they query the last year's worth of data. And there's quite a few of these. We're only going to use a basic level of them in this dashboard tutorial, but it's just an FYI. These are really great for making your dashboards more dynamic. Now, once we've done this, We're then going to show you a transformation in Grafana. We're basically going to show you how we can actually transform our data while we're querying it as well. And we can do that using a partition. And the reason we're going to use a partition there is basically so we can partition our different streams of data from the table based on generator ID. Sounds good? Sweet. So I will do this now. So if you look in your Scratchpad, what you will find is let me just make this a little bit bigger, and let me reduce the size of this. If you look in your Scratchpad here, you'll see on step 19, you'll see the select time fuel generator ID from gen data. So if I copy and paste this query, jump back over, and what I'm going to do instead is go edit SQL, switch over, copy and paste this in, like so. And if I navigate, I'm going to say just do this for the last 15 minutes. We're going to get what we see at the moment is a really odd line graph. And that's basically because if we look at the actual table view or the raw table view at the moment, Grafana doesn't quite know yet how to differentiate these different generator values in the generator ID table. And so this is why we're going to use a transformation to basically partition by that generator ID. Now, if we wanted to, we could use a format by time series, which we have the ability to do. But for this case, what I wanted to do was show you how basically we can transform flat tables, like you see here, into real time series data that we can partition by. Just to give you a show here. So what we're going to do is we're going to click transform. We're going to search directly for partition. And you can see here we're basically going from split one frame data set into multiple series. If I select this and click the field, we're going to select generator ID. And what this has done is generated 3 different tables for our generators, basically partitioned by that generator ID. Yeah? If I then toggle back off of table view, you will now see a much better looking line graph which contains our fuel levels for each of the different generators as they go up and down. So I'm just going to give this a nice basic name, fuel level. Click apply. And I always recommend, this is the major woe with Grafana, just FYI, is make sure you save your dashboard. If you refresh your page and you've not saved your dashboard, your changes will not be saved. So they're great for version control, but there's no auto saving when it comes to Grafana in this case. So I'm just going to call this demo dashboard. As you can see, I'm a creative at heart. There we go. So this is the most trivial visualization for time series we could ever do. It's the humble line graph, but sometimes it's always the best one to start off with in terms of looking at trends in our time series data. So before I move on to the yeah, go for it. Yeah, I can jump back into it. You got it to do. Yeah. So essentially what you need to do is search for partition in the drop-down. That's it. And then what you're going to do is select the field generator ID. Yep. Ah, okay. It's just because there's data stopped coming in. So we do like the last 15 minutes. There we go. And then if you go partition, if you type partition in there, you scroll down, there you go. Okay. If you select on the select field, if you go generator ID, and then that should be it. There you go. Okay. No worries. Could you hover over the error? So I think, are you running Cloud TSM rather than v3? Which cloud instance are you using? No, but oh, you made a new one? Yeah. Okay. Yeah. So if you jump back into your. So you are getting results there.
Yeah, that gave me that error before, but when I ran the query, it got. How did you actually run the data?
So if you just run the calc.
Like this?
Yep. Okay. There we go. Oh, phew. Okay, and we should have this jigsaw effect here that we've got. Sorry, this saw effect, which is you see a lot in terms of OPC-UA production, just to show that we're getting values. So the next thing that we're going to do is we're going to apply a geomap visualization to our graph. The idea here is we're going to say, hey, we want to give the last fuel value known from that engine, and we basically want to plot our engine based on our longitude and latitude on the map. This will give our engineers the ability to know which engine is running out of fuel and go and refuel it. This may sound ridiculous, but in my previous company, there was actually a use case where this was vital to their operation. They had several engines that would constantly run out of fuel, and this was like bread and butter to them. This was fantastic that they could actually see which engines were low on fuel. They could drive to them, plot maps, etc., and work out where they needed to be. So we're going to do a very basic example of this visualization today. So we have this query here, which looks quite a lot to comprehend. But really what we're doing is we're basically requesting here is we're saying, using this command select to last, I want you to give me the last time and the last value for the field fuel. So this is going to give me time and the value for that last. So the idea is because the way we've done it is because basically with select to last, you return a JSON payload in this instance. And this says the JSON payload will have the key time and the key value. And we're basically saying, give me the time and value for that. So this is what happens with select to last. We're going to also request the generator ID because we want to be able to partition by that generator ID. And we also want to know the last lat and long for our generators. Now, I'm not expecting our generators to move anytime soon, but we want to know the last known value for our longitude and latitude. We're then doing, of course, from, so we're getting that from our gen data. We're using our trusty dashboard variable, once again, time range. Now, what we're doing here is we're grouping by free. So essentially what this does in Postgres land is says, group by the third entry that we have in our select statement. So we're grouping by generator ID. So we're making sure we're getting the last value for each of those fields from each of the generator ID. So generator 1, generator 2, generator 3. Otherwise, if we didn't do that group, we would just get the last value from one of the generators. Yeah? Okay, we'll come back to that in a second. So if I jump in, click Add Visualization, if I go from my drop down, and what we're going to do is we're going to go to Map, so a GeoMap panel, which just gives us our world map here. We're going to go Edit SQL, and then what we're going to do is jump back into our trusty Scratchpad, wherever that may be, and we're going to copy our pre-made query for us here. And I'm going to paste this directly in here. And as you can see, we scroll down on the map. I'll show you how to zone this better in a minute. we can see that we've plotted our 3 different generators onto the map. Now, notice we didn't actually have to add a transform this time, and that's purely because we're grouping by those different generators, which gives us our 3 individual visualizations or series for that. I mean, what we can do is we can jump into the table view and show you exactly what that looks like. And as you can see in this table view, we have generator 1, 2, and 3 with our lat and long and our fuel levels. So it's looking okay, but it can be a lot better. Where it's not really telling us anything at the moment except for the locations for our 3 generators. So let's do a little bit of transformation in Grafana to make this look a bit more interesting. So we're going to change the view to North America, because it's actually North America that's critically running out of fuel for now, which is quite an interesting dystopia. Let's hope it doesn't happen. And we're going to change our coloring to the field fuel. So this is how we're going to be thresholding our colors. We're then going to update the thresholds in Grafana and basically use a traffic light system to indicate when we're going to run low on fuel. So, without further ado, I'm going to give this a name really quickly. Just going to call fuel level map. I'm going to scroll down. We're going to change this view to North America, like so. I'm going to scroll down again. And we're going to change our color here from fixed color to fuel. And then I'm going to scroll right down to the bottom and you'll see our threshold mapping here. Now Zoe, correct me if I get this one wrong. I think it's above 500, like green is 500. 250. Yeah, we'll go with that. Go 100. Okay, and as you can start to see, we're now traffic lighting our fuel engine data. So we have one of our engines which is pretty high on fuel. It's above our 500 threshold. We have another one that's getting a bit close, and we have another one that's pretty critical right over here. So we can actually hover over these as well. And this gives us basically our location, the timestamp this was taken, our fuel level, our latitude and longitude specifically, and the generator ID in question. I'm just going to click apply, and then we can have a bit of a move about just to make the visualization a bit clearer. And always hit save. Awesome. Did we all get to that point? Ish? Yep. So we go down on the drop-down title fuel level map. In the map view section, you're going to change the view here to North America. You scroll down once again. So this is now under map layers. You'll have color, which will be fuel. You'll change that from fixed to fuel. And that'll just make sure that our thresholding is under that fuel column. So just the color from, you'll probably see something like fixed color, and you want to change that to fuel. Yeah. So if you scroll down just a bit, and then change, keep, yeah, that's it. Oh no, wait, oh no, you're right, sorry, change that one, and change the fixed value back, because it's just going to make your, change that one to, yeah, change that one to fuel. And then if you scroll up and change that one, the size back, because the size changes the circle area, and just do fixed value. Yeah, perfect. Yes, perfect. Okay, did we all get to that point? Are we seeing a map, helping these generators out? And we should see something that looks like this. Now, it's going to be randomized for each of your own simulators, so you'll see this all over the map, depending on where you are. Some of you might see it in the middle of Hawaii. It just depends on where the randomizer sent you. Okay, had a bit of a progress check there. We all doing okay? Now, before I move on to, we've been sitting here for like 2 hours something. So would you guys all like a break? And you guys can go chill and take a breather. You can come back if you want to. You don't have to come back. Up to you. So we're in the home stretch. We're in the last bits that we need to do. So well done for sticking through. So what we've done so far is we've been quite reactive in what we've developed. We basically said, here's a dashboard, we've collected the data, and we're basically giving the engineers a view into what our generators are doing. Now, the problem with this is someone's going to have to be there 24/7 looking at this dashboard and checking whether the generator is running out of fuel. So how do we become proactive rather than reactive? And the best thing to do this right now is alerts. So we can do this all within Grafana, and what we're going to do is we're going to create a managed alert in Grafana. And this works a little bit like how a visualization does. We can basically give it a query. We can then basically then use the data returned from that query to then say, okay, if there's a certain issue with my data, if I'm going below a certain threshold, then I want to be alerted to that. And we can notify our engineers on a series of platforms. So this is what we'll do now. I'll take you through a quick step-by-step process of doing the notifications. Now, you don't have to follow along if you don't want to. We can try our best to do this together. I do find the alerting in Grafana quite, you do have to drop and change between lots of windows. So I'll try and do it as slow as possible so you can see what I'm doing, but just let me know if you want me to stop. Just give me the shout. So the first thing that we're going to do is we're going to start by creating that managed alert, and we're going to supply our SQL query. Now, this screenshot was taken from from Grafana Cloud, so you might not need to do this step here when we jump into OSS, but you'll see that in my instance. You might just have a Grafana managed alert preset. So if I scroll, let me check where my thing is. There we go. If I scroll back in, we have our lovely dashboard that we created earlier. I'm going to do my drop down on the side, and what you will see is you will have alerting down on that drop down. Once I click alerting, I'm presented with this whole new panel. It has a lot of things on it. The thing that we're going to start off with the most is we're going to start off with the top one, which is our alert rules. So you're going to click alert rules. And what we're going to do is we're going to create a new alert rule. So click create alert rule. And what this does is starts predefining what we saw in that screenshot. So what we're going to do is first give our alert rule a name. So we're going to call this fuel check. And then for our query, we're going to actually just change it to edit SQL like we've been doing. Like so. We're going to jump into our trusty Scratchpad and Visual Studio Code. And we're going to take this step 21, select generator ID, time, fuel, and using that trusty dashboard variable again with the $_ time range. Now, it's important this time that we use this function here called order by time. So we want to make sure that our timestamps are ordered by that date time field, and that allows us to translate our data into time series within Grafana, so they have 3 formats. They have time series, table, and log. And so basically with this plugin, it defaults to a table, but if we want to make sure we can convert our data to a time series format, they basically make sure that your data is in timestamped order. So we do this, we copy and paste our query in, and what we're going to do is we're going to select, instead of table, we're going to select time series. If you scroll down ever so slightly on your page, you'll see this button called preview. If we click preview, you should see a visualization that looks a little bit like this with a red bar that's at 0. Let's have a look. How's everyone else doing? Okay, no? No, we imploded on each. So, yeah, and then if you do the drop down here and put that to time series, and then if you scroll down, and then hit preview. Sorry, the blue preview button. There you go. Nice. Awesome. Time series, order by time. If you scroll down and then hit preview. So no data results. If you scroll back up. So in generator ID, time, value. Are we still getting data for you? Let's see if we can go. If we do, we've got 10 minutes worth at the moment, but maybe we click the options. If you change that to say 30 minutes. Oh, so you might have like just build Docker. You might should be able to just spin. Oh, you give that a refresh and see if they're all down. Well, they look like they should still be up, but interesting. It looks like the data stopped going. What you can do is just give maybe Telegraf a restart, and that might get the data flowing again. It might just be Telegraf that's. See. Yeah, it should be okay. No worries. But you should be able to still follow along even if you do like the time range is like 30 minutes or something, just get the last ones. Okay. So as you can see here, we now have our fuel levels again, and we have this red bar down at the bottom. So this is our threshold check, and we're going to change this next. So this is just showing you here. Making sure I've got all this right. Okay. So the next thing that we're going to do is we're going to configure our thresholding. So at the moment we have two expressions at work here. We have our reduce expression. Essentially what that is doing is saying for all of the time series data that we've got in from our query, give me the last value, and the mode here is strict. And so it's giving us the last value here for generator 1, generator 2, and generator 3 based on that data that we've returned. We're then passing our results from B into C, and we're basically going to say if any of these generators fall below 200, then we want our result to fire. We basically want that check to become an emergency, that our fuel levels have dropped lower. So let's start off by doing that now. If I scroll down, what I'm going to do, as you can see, reduce has already been predefined for us here. I'm going to then go change this toggle from is above to is below. And then I'm going to change this to 200. And then we can click preview again. And then as we can see at the moment, our generator, this is going to stop erroring out. I think it's green, so our generator 1 is dramatically below our threshold line at the moment. So as we can see, this is considered firing by Grafana because we've got an emergency. This is below our threshold. How are we doing? We doing okay? Got there? So, now that we've kind of defined what our threshold behavior is going to be and how we want to alert, what we need to now define is how that behavior is going to be checked. And this is the only bit I find the most confusing in Grafana. It took me a bit to learn this myself. What we're essentially going to do is we're going to create a folder which allows us to define basically a group of alerts, so we can have many groups in one folder, and it's how many times we want Grafana to check this interval. So maybe we want to check it every minute, we want to check it every 5 minutes. This is how many times we want our threshold check to run on a time interval. The next thing that we want to do, sorry, that's part of our evaluation group, my apologies. The folder is just probably purely an arbitrary directory of where we want to keep our alert. The evaluation group is how regularly we want to check our evaluation. Now, the pending period is a feature that is quite interesting, and the fact is, so let's suppose we have our fuel engine, and for whatever reason, the fuel engine has a bad sensor reading, and our fuel level drops below 0. It's a bad reading. It's not what we expected. Grafana's not going to know that. It's just going to consider that an alert. So it's basically going to say, hang on a minute, your fuel levels drop below the threshold. I'm going to start telling all the engineers that there's a problem. What the pending period allows us to do is guarantee that is an actual alert. So basically what it does is says, in this case for 5 minutes, if our fuel level stays below that threshold on each check for that 5-minute period, then I want to be alerted rather than being alerted on every time. And so this just adds a little bit more logic to our query, into our check, to make sure that we're only getting alerted based on a logical rule rather than just every so often, because otherwise we just get spammed with alerts. So let's quickly do that now. I'm going to scroll down. What we can do is create a new folder for our alert. I'm just going to call this generators. Click create. We can then create a new evaluation group. I'm just going to call this fuel check. And then I'm going to, just for purposes' sake here, I'm going to set a 10-second check on our interval just to make sure that we get an alert really quickly as part of this demo. So we're going to check every 10 seconds our fuel. And what I'm going to do is I'm going to drop this pending period right down. I'm going to say, if the fuel level is still below our level for 20 seconds, then I want to know about it. Okay, are we okay with that bit so far? Sweet. And that's us done with our rules. So what we can do is we can go save rule and exit. Now this check will continue to run every 10 seconds. And so it will basically fire if there's an issue with our fuel generators. But what this doesn't do is it doesn't link us up to a notification point. So the last thing that we need to do to complete the circuit is create a contact point and notification policy. So was this in, yeah, this was your, like in annotations. Yeah, I've got it. Fuel is low, this was in, yeah, okay, notifications. Okay, so the next section in the visualization is what we're going to do is define a notification rule. So what we can do here is, this is where I get myself lost in Grafana. I'm just going to go back because it's easier to do this rather than do slides. The first thing that we're going to do is create a contact point. We're going to go in linear order. Sorry, I was getting myself confused there. What we're going to do is we're going to add Slack to this. And the only thing that you don't have is I'll probably do this for you on our behalf because I haven't given you the Slack hook to be able to do this yourself. But essentially what we can do is we can go add contact point. We can then create a new contact point. So I'm just going to say Slack for this one. We can then check from the drop downs that's available from Grafana. As you can see, there's quite a lot that's available to us in OSS. In this case, we're going to chuck a Slack. And then what we're going to do is we're going to provide a webhook URL. So I'm going to get this from our Slack channel. We have basically in our Slack community a notification channel that people can test notifications with. So if I jump into our threads here, if I go Slack, I think it's notification testing, and I have this webhook up here. If I copy this link, unfortunately, sorry guys, I have no way of giving it to you. I didn't prepare for this bit. So if I jump down, copy and paste this URL in, if I hit test, as you can see, I'm just testing to make sure that I have this connection available. It sent an alert to our test notification in Slack. And as you can see, we've got a firing alert here. So we know that connection works. So, sorry, the webhook, you got it because you are an admin of the Slack Correct, yeah. But what we do is, if you're part of our Slack community, we do leave the webhook just in the notification testing. But you
need to be a Slack admin of whatever Slack in order to get either the token or the webhook.
Well, you can get this webhook from our Slack.
But,
like we
yeah, which
posted
means
it.
I need to subscribe to your
That
Slack.
is true.
but you can use your own Slack, and then as long as you're an admin of your own Slack, then you can basically do the webhook yourself from there. Yeah. There's obviously other options. If you're using Grafana, and you have SNMP that you can configure. You can do email, you can do all that. If you're using Grafana Cloud, all of this is managed and maintained, and you could just set up email through that. Okay, so with that being done, I'm going to go save contact points, like so, and hopefully we should have our Slack there. The last thing that I need to do is, if I go to notification policies, what I'm going to do is I'm going to modify our default policy, and I'm going to change this from the default contact point to Slack and update this default policy. And what this will do is make sure that the default notification is Slack. What we can do is have loads of nested policies underneath this. So we can say, under this certain condition, we'll notify this set of engineers. Under this certain condition, we'll notify based on an email, and so forth. So Grafana can get pretty intricate when it comes to its alerting system. And this is why you see quite a lot of the complexity that you see here. It's just quite, it's highly customizable. And then hopefully, if we give it a second, we should see firing. So we should see our fuel check here is firing in my system, because we've got one that's considered alerting, which is generator 2. And that's been alerting for so long. And what we should see in Slack, if I jump back into Slack, hopefully, if I can get back to Slack, is, as you can see, we have our fuel check generator, and it's firing generator ID generator 2 from this, and you can see the value at which it's firing. That's because it fell below the 200 threshold. And skip on with these a little bit. And then, of course, there's plenty of other options. You can actually set up quite a lot of automation for your alerting process, and you can set up alerting rules using Terraform, and external alert managers as well, all through Grafana. Okay, sorry, I didn't get you guys to be able to, that wasn't so hands-on for you guys. My apologies for that one. For next time, take note, give you guys a Slack webhook. But hopefully it gave you guys an idea of how to use Grafana alerts. So we did just do a fuel break. Are we okay to do the final section with Zoe? And then I think we'll be able to round out our workshop. Awesome. Right, I will pass back over to Zoe for the last section, the data.
All right, let's go ahead and wrap this up. So we're going to go ahead and do some SQL one-on-one, and specifically SQL related to time series. So really quick, I want to just say something kind of funny here, I suppose, which is that most of you guys, when you hear SQL, you think of the querying language, SQL, and you probably also think of relational databases, also called SQL DBs. InfluxDB is technically considered a NoSQL DB because we're not relational. So, and a lot of NoSQL DBs actually don't have SQL capabilities. They can't query in SQL, the language. That's actually why they originally got the name. Though what's funny about that is that the SQL language, similar to Java and JavaScript and their relationship, when relational databases were created, they decided to name them SQL, and they were working on a language to be able to query the information out of these databases, and originally it was called Square. They didn't like that. It didn't take off quite as well. So they did the very smart thing of naming it the exact same thing as the DB. So that is why when people talk about SQL and NoSQL DBs and SQL, the querying language, things get kind of confusing, especially in our modern world, because at the time, the idea of a NoSQL DB was just wild. That wouldn't be a thing for about 30 years or so. So at the time, this worked for a very, very long time. But nowadays, it's a little more confusing because Yes, the SQL language can actually now be used in NoSQL DBs. Yeah, Jay's going to run around and give you all little gifts. So we're going to really quick talk about querying within the SQL InfluxDB Cloud UI. We're not going to have, you don't have to use these right here, right now. We're just kind of going to go and walk through them. The select clause, as in most SQL, specifies the tags and fields from which the data values are to be retrieved. The from clause specifies the measurements tables from which the data values are retrieved by the query. And the where clause specifies where you would find those records. So there's a lot of jargon. Let's go ahead and use an example here. So traditionally, you would say something like, select the column from the table where the conditions meet X. So for example, select my user from my persons table where they are still alive. That's a good one. But in time series, it's a little bit different. You'd say something more like, select the tags and fields for this one. It could be something like temperature from the measurement of factory number 2 where the temperature is below 70. That would be a more apt way of looking at this. So just something to keep in mind here is when it comes to, I don't really want to get too much into the quoting. This is just something to understand, but basically just do keep in mind that this would be the process order. You always start with the select, the as, the from, the where, all of these wonderful things. Like for example, I was using one like exist. That's another one. The group by, the order by. Again, this is pretty common SQL querying. This is not per se specific to time series, but this is a normal process order that we would expect. And you'll see this as I go through a few of these queries. So we're going to start with the basics, which you've kind of actually already done these. This is some documentation. This will be available. This is available online, basically through our GitHub. We have parts of this slide deck. This one's a bit longer than our normal, smaller one, but I'm just going to let you know that these basically just go back to the documentation on Influx. And we'll have a QR code at the end of this. So how do I return all the data from the last 10 minutes? So this is pretty straightforward. So we want to select everything from gen data where the time interval from now to minus 10 minutes. That's basically exactly what this is saying. This is something we've been doing for the past, throughout our workshop here. We've been doing slightly different intervals, and a lot of them have been drop-downs. Like in Grafana, it was a drop-down. In our own UI, it's a drop-down where you just say, like, give me the data for the past hour. But when it actually writes it out, this is how it's writing it. And this is roughly what we would expect to see. So how do I return all the fuel values lower than 100? A very similar concept here. Again, something we just use for our alerting. We want to select the fuel and the time and the generator ID from gen data where the fuel is less than 100. So what we're doing here is we're basically selecting these three because they're the most important pieces. There's other pieces, like if we go 2 slides back, you can see we've got other pieces. We've got power and latitude and longitude. Location might be empty, but it's still there. We even have timestamp. In this one, the time comes along because that's just how a time series database works. You don't have to, or actually, sorry, let me rephrase that. We're requesting the time, so that's why we're getting it back, but that's a pretty normal one to request from gen data. And with this, we're saying only give me back the generators with the fuel lower than 100. When we ran this query, you'll see generator 3 has disappeared because it happened to have a fuel higher than 100. So one thing that we offer, and depending on the SQL version, language, DB, just depends on what you're up to, you'll be able to use things like aggregator, selector, and time functions. So specifically, we support aggregator functions like the average, the min, the max, the count, and the sum, which is very helpful. We also can do this across timestamps with our average, count, and sum. You can't do like the minimum timestamp because that's not a concept. There are also they have an even longer list of aggregate functions that are more general, statistical. We also have the SQL selector functions, which are specifically designed to work with time series data. So that's the other thing too, is that there are more aggregate functions than these ones, but these are the ones specifically that most people with time series data would prefer to use. And then we also have these ones, things like selector min, selector max, selector first, and selector last, which actually we saw this one during the map one that we did in Grafana, we were using the selector last. And again, this documentation will be available. We have the QR codes at the end. And these are the general aggregate functions, just listed out here, making it easy. I'm not going to say what these are because most of us here have taken Math 101, so I'm going to guess we all roughly understand them. So really quick, what is the min, the max, and the average fuel level? So when written out, we would say we want to select the minimum fuel as min fuel, which basically what we're here doing is we're describing what we want the table header to say. We want the max fuel as max underscore fuel, the average fuel as average underscore fuel. All of this is coming from the gen data table. And we're specifically saying that we want this in the past 10 minutes. And we also want the generator ID as well. Or sorry, we want the generator ID to equal 1. So this is just from generator 1. We don't want the information from generators 2 and 3. We just want the first one. So this, in the past 10 minutes, is the max fuel it had was 960, and the min was negative 69, which does not seem ideal at all for our fuel generator. And the average was 389. This is what you get when you deal with random number generators. You get some really funny queries back. But basically, this is obviously very nice and easy to read, and as we talked about before, no timestamps because these are not relevant to time. There's no max time per se. Outside of the fact, I suppose, you could get a timestamp for when the max fuel was at that level. So these are some of our statistical aggregate functions. Again, the reason that they're lit up blue is because they're links to the actual values. I'm not going to go into each of these individually, especially because I actually don't use all of them. So I'm not big into statistical aggregate functions. It's just not my wheelhouse. But we're going to come back to those. So grouping with SQL. So you can also do those aggregate functions that we just mentioned with group by. So you use group by to group one or more fields or tag columns. You are required to use group by before a having clause. We're going to get into the date bin function, which will allow us to group data by time intervals, and the order by function, which basically just changes the order of the results. So this next query is going to involve all of these. So with this one, we're selecting generator ID. And when we do this select, this time we're going to see all 3 of our generator IDs come back because we're not just selecting one of them. We're saying date bin interval 1 minute. And basically what we're saying here is that we want the average fuel for the past minute as the mean fuel from gen data where the time interval has been the past 10 minutes. We want to group by group by to generator ID and order by to descending. So what that basically is saying here is that we're grouping all of this information into the generator IDs. So when we originally do the average fuel, if we were not grouping by the generator ID, we would get a really weird result back basically because it would average them all out together, like all 3 generators, and that wouldn't be very helpful for us. So we're grouping it by generator ID, so we only get the mean fuel for each one. And we're ordering by to descending because we want the top 2 to basically be the top lowest ones. That's why we're saying order by descending on this one. And what that date bin interval is doing is basically taking within those 10 minutes, just in case the data was in multiple like nanoseconds or anything like that, it would only be giving us, it's like aggregating it basically beforehand. So another thing to take note of, which I didn't use for like a real querying here, is something that we have specific to us, which is date bin gap fill, which basically what happens is sometimes you end up with empty slots. For some reason, your data doesn't come all the way in through, like for example here, the temperature just seems to be skipping randomly. We're getting the timestamp, we're getting the room it's existing in, but then it's just kind of randomly not coming in. And so what date bin gap fill allows you to do is it allows you to infill this. So you no longer will have these null values. Well, one thing also specifically to note is what this one's actually doing first is it's actually adding some of these in. So sometimes you actually get data where this is actually missing. This null value entirely is missing. But what this will allow you to do is not have this random null value within the time. It'll allow you to input them. For this one specifically, it's doing the interval every 30 minutes because that's what the data already had. So for example, living room seemed to skip between 9 and 10. There wasn't a 9:30 slot, so it went ahead and added it. But when it does this right now, this one doesn't have anything that tells it what to infill this empty temperature with. So if we go ahead and we say we want to interpolate this one, what it will basically do is it will take the average temp and it will go ahead and pop that average into the empty slot. So I'm going to go one more back here. So we're going to pay attention to kitchen number 2 slot here. So as you can see, it's taking the average of 21 and 23 and making it 22. And this one's a little more complicated because living room has lots of dot values. That one's a little more straightforward, but it's doing the exact same thing. Another one we offer is called LOCR or locker. It basically, what that one will do is it will take the last temp and push it forward. And I don't have a visualization here, but basically it would, instead of doing an average, it would take 21 and make this 21. Now that is really helpful when you're dealing with missing data points at like the second range, because unlike our random number generator with fuel that seems to jump around all the time, on average, if you had a gap of 30 minutes and your fuel went from 960 to 966, you could probably just go ahead and let this empty fill in be like 960 or the average, and it would probably be okay both ways. But basically, when the gaps are smaller, it's a little better probably to use the locker function. I was about to say, is anyone being blinded by the sun here? Well, I can't move those. So no going back to the statistical aggregate functions here. So math across measurements by joining tables on time. So here we're using our correlation. So one thing to keep note of here is that our data is not very well correlated, mainly because of the fact that it's so random, that even if we were to correlate on fuel and time, it still just wouldn't quite look right. It would basically not really have a good correlation because, as you guys already have seen, our flow rate just kind of jumps around a bunch. So even if you waited 10 minutes, the fuel could go up instead of going down as would normally be expected. But what this allows us to do is join a second table, which we currently don't have, but maybe we had a second table with other generators, which is what we're going with here. We would expect to be able to join those other generator tables on time, basically. And with this one, we're expecting the same kind of like time interval of 10 minutes and the same generator ID of 1. Or actually, specifically this one we're expecting is another table with a generator ID of 1. Maybe we're storing the minute data, that non-downsample data that we started with earlier in the workshop, and now we want to combine them together. And from there, we would be able to tell the flow rate of the data. We'd be able to tell how much fuel it's using over time, and it would tell us the correlation. So one thing I want to take note of is taking advantage of ChatGPT to craft your SQL queries. I know, what a cop-out. And funny enough, I didn't actually use that for this slide deck, but we have started to suggest this to some of our community members, because this is one of the nice things about using SQL in our DB going forward, is that people can leverage all of the SQL documentation online and all of the SQL resources available to them. And so I do suggest checking this out. If you ever need to write SQL queries, ChatGPT is actually quite good at it and quite helpful, though don't trust it fully on anything, but it's a good starting point. For example, this one's pretty good at asking for the highest maximum temperature. You can use the following SQL query, and this is pretty spot on. Obviously, you would have to swap out possibly your DB and such, and this one has limits and offsets, which we weren't using, but overall, this is a pretty good start. So, thanks to all of this workshop, we have now provided a solution to the generator maintenance team. Using Telegraf, we tapped into our generator's health stats and sent them to a local instance. We solved our issue of intermittent internet connections with our edge-to-cloud replication. And of course, we improved our visibility by using dashboard and notification solutions hosted in InfluxDB Cloud and Grafana. So where do I go from here? So these are some of our client libraries. So although we were talking mostly about Telegraf, we do like to highlight these for people who are going to be taking this out into the world and maybe can't use a Telegraf agent. We have our client libraries, which are in multiple languages. That makes it very easy if you are working in one of these, and most people are working in one of these 5. Obviously, we have other people, but those are the major 5. And with this, you can do any RESTful API calls. You can read, write, delete your data, etc. You can onboard with the client libraries on the web or with the CLI. You have both options. You can deploy it yourself. So this is our GitHub file here. That should have a link, I believe, to Killer Coda on the GitHub. Yep, awesome. And so with that, you can take the Killer Coda is more of a walkthrough. This is less of a full walkthrough like the slide deck has been. Obviously, there's no one there to, per se, answer questions or anything. It's more about just getting it up and going. But still, also one thing to note is this will be fully fledged from what I remember. You don't have to fill everything out. Or no, actually, I think you still do have to fill some stuff out. Yeah. Yeah, that's right. But yeah, Killer Coda allows you to kind of speed through things, but it still explains everything. So if you ever need to go back, if something didn't make sense, this is very helpful for learning at your own pace. You can, of course, join InfluxDB University, which is where we have all of our courses. It teaches you things about Telegraf, about the cloud. Some of it is more relevant to V3. Some of it's a little bit not quite relevant yet. We're working on getting everything up to speed, but that's also what brought us here for this workshop. Here are just a few further resources. The Getting Started, you guys already know because you've already been on the InfluxDB Cloud. The forums in Slack are great for asking questions. Obviously, Jay and I are active there. If you ever have any questions, please feel free to ask. The GitHub Influx community is where we keep all of our workshops as well as our other small projects. We also have our docs, our blog, and InfluxDB University. And if anybody has any questions, you're welcome to ask them now or later. But I think for right now, we're probably just going to go on ahead and wrap up, and people can just come up and ask us questions as they need to. So thank you so much for coming.